3, 2, 1, go.
Feels like Olympic.
Hey, welcome back again to GDG Nairobi Cloud Next series, and we are on to the last session of today's event. Whoop, 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 whoop. We're going to wrap up this session today with our very own GDG Nairobi Lead. I don't know if you guys know him. I'm sure you know him. You heard from him maybe on different platforms. Today he'll be taking us through digital transformation with Liquid IoT and Google Cloud. He's really passionate about IoT. I'm really glad that he's going to share, like some of this knowledge with us today. So Marvin Ngesa is an electrical engineer. Like I mentioned, he's the lead community organizer at GDG Nairobi. He's an educator. And he has great passion for interfacing connected electronics with software and AI. Yeah, you can see him there with his, beautiful bicycle. Maybe he will tell us a little bit more about, the inspiration from the whole, picture. Maybe it has something to do with IoT and electronics. We never know. So, Marvin, are you ready?
Yes, definitely, Tabby. Thank you so much for the kind words and the introduction. My name is Ngesa Marvin. I am an Internet of Things engineer with a company called Liquid Telecom. And today I'm going to show you how you can connect your devices to Cloud IoT. So apart from Liquid Telecom, during the weekends, as Tabia said, I also help work together with Wayne to run events on a bunch of Google products, such as Firebase. We had a very awesome Firebase event. You should, in fact, subscribe to our channel and check on the Firebase events. We also have TensorFlow events and even Google Cloud events. And we're not stopping there. We are also going to organize more awesome events. We have Deft coming, which will be fully on one epic weekend. So at work, I help connect clients to our network. My day-to-day role involves helping clients and helping developers and engineers to be able to onboard their devices on our network and be able to create pipelines in the different cloud platforms so that they're able to connect wireless networks to cloud and from one cloud platform to another cloud platform. And Liquid Telecom is known for building network infrastructure across the country, from Mombasa all the way to Nairobi and all the way to Kisumu, western part of Kenya, and also across the continent. In fact, we have a fiber network that is running from Cape Town all the way to Cairo. And in between the fiber network, or rather at strategic locations on the fiber network, we're having data centers. And data center is what we're calling a cloud. So what you're seeing on the right is, in fact, the Nairobi data center, or rather the African data center in Nairobi. And this cloud has always enabled us to be able to get data from it. For example, right now, if you search for video on YouTube, it should come from, let's say, a Google data center and come all the way to your mobile phone. You can also use your laptop to be able to access data from a data center, images, videos, web applications, streaming from data center through a fiber all the way to antennas, and finally to your mobile phone or to your laptop if you're using a wireless network. And the good thing about this cloud is that people are always able to access cloud from anywhere and from any time. You can always use your mobile phone or your laptop or your tablet to be able to access videos on YouTube or Netflix or go to Facebook. And you can do it anytime and anywhere. But what that work has been largely for people. It's been you and me accessing this network using our mobile phones. Right now, you're accessing the internet, or you're accessing YouTube using your laptop or probably a mobile phone. And this one has been largely people using the internet. It's an internet of people by people, and all the content is also from people. But recently, Liquid Telecom launched a new network that enable people to connect things. And the question is, if you can connect people, and if you can enable people to access the internet, and enable people to add data to they're able to add images and videos to the internet. what if also we're able to enable things to communicate to cloud and send information to cloud? Different people, or rather, the internet of people has enabled new companies to come on board. We have companies such as Facebook, since we had 4G and 3G network, to be able to offer services and reach people globally. We have companies such as TikTok right now, which people are able to access their products because of the internet of people. But what if we can also give things the ability to send data and to communicate and enable different companies to come up with different business models and different services, because they enable things to communicate with each other. The same way that when we enable people to communicate with each other, we came up with new business models and new companies. In fact, 4G network and 3G network enables companies like Google and Facebook to reach people globally. So, and if I talk about thing, I literally mean anything. And a connected device, the one on the top, is basically a small processing unit, a small hardware, a small unit that is able to read data from the environment, that is able to read temperature, humidity, moisture, and then do some processing in the background. And processing addition, subtraction, division, or checking some logical comparison. Is this temperature greater than this other one? And once you have the data, maybe it may not be useful having the data locally. It's probably if you're able to take it to the cloud, you're able to be able to connect it in the Internet of Things. And you can do this directly to cloud, or do this through a gateway, like the one on the right, where you have antennas and gateway listening to your device, and then they forward the message to cloud. So we have seen how things communicate, and I've also seen how people communicate. And because of our expertise in the network, we believe that the Internet of People should be different, completely different from the Internet of Things. For you to be able to watch this video online, you need a very big bandwidth to join this call. For you to be able to go to Netflix, you need a very big bandwidth to join the call. But if you're using a very big bandwidth, it means that you're going to consume of power with your device. And it means that after every 2 hours or 3 hours, phone. But imagine thousands and thousands of soil sensors in a farm somewhere kilometers away. And imagine if after every 1 hour or 2 hours, you'll have to change it. You'll have to charge all of them, get all the thousands of devices and charge all of them. So we've come with a complete new network that allow these things to send small amount of data, to send data such as temperature, data such as humidity, and data such as location, fuel consumption over the internet, all the way to a cloud platform through a global radio network called Sigfox. This network is in 71 countries, and we have millions and millions of devices connected, and also millions of messages sent over the network. In the country, we work very hard to have the network deployed across the country, as you can see on my map. In fact, the red parts means that there are at least 3 base stations listening to these from these devices, and the green color means that we have at least 2 base stations listening to the messages, and the blue means that we have at least 1 base station listening to the messages. So covered, you can see Lamu, Garissa, Mombasa, Nairobi, Kisumu. Today we're going to do a demo with you on a device which is somewhere in Nairobi that is sending data all the way to BigQuery. So the way it works is very simple. On the left, you have an IoT device. You have a connected device, a device like your mobile phone with some things you move from it. A device with a radio that allows you to only send small amount of data, but also enable that device to last in the field for many years, as many as 15 years and 16 years. These devices include things like water meters, include things like trackers that are able to send location information, temperature information, humidity information, or fuel consumption. And once they send this information, from the left side, we have antennas across the country listening to these messages. The antennas will grab these messages and then forward it to one Sigfox cloud. And once they're on this cloud, you can easily attach APIs. You can attach a server, so that once the information is sent to cloud, then automatically you can be able to push it to these servers where you're able to ingest the data, process the data, manage it, store it, and even visualize it on a platform. So Google is almost doing a similar thing. Google has fiber network across the globe. They also have data centers, and they're also providing services on top of the data center or the cloud. The trend that companies are doing right now is that they're combining something called communication technologies, where you're combining the network and you're combining the radio network, the 4G, 3G, the 5G, and combining it with the IT technologies. So I think there's a convergence of communication technologies and IT technologies. So today, on my left, I have a which my colleague is having. I mean, my colleague is having a device that is Kenyan made. It's a Kenyan made, probably first Kenyan made dev kits that is collecting data and sending that data through Sigfox network all the way to Google Cloud IoT. And Google Cloud IoT is basically a fully managed serverless architecture devices to be able to collect data from the environment and send them all the way to and ingest them on Google Cloud and process the data and then be able to store that data somewhere in a place like BigQuery or Firebase. So architecture, but I'm going to remove some things so that the architecture is very simple and the pipeline is so simple, where and to cloud functions and then to BigQuery. So these are a slightly simple architecture, where on the left you have a radio network, you have devices sending data through network or over a radio network, and then you have APIs in form of cloud functions that are listening to events from the devices or from Sigfox Cloud. And once a device sends a message, or once we have an event on the backend, it will trigger that callback, and the callback will grab the message or the data and then process the data, because sometimes the data is normally in base 10. Sometimes the data is in base 16, hexadecimal. And also, most of the time, this data is encrypted. So you have an encoded, encrypted data. And when you receive that data on the callback, then you need to process it. You need to decrypt it and then decode it. Once you've decrypted it and decoded the data, then you can forward the data through PubSub, or take it or create a data flow pipeline and send it. Or you can just have the cloud function grab the data and take it to BigQuery directly. And also you can connect other as callback services that are able to enable you to be able to and check on the loggings of the data. So this is the device that we're using. That is Kenyan made, and this device, as you can see, it has a bunch of ports and sensors. You can see there's a temperature and humidity sensor, which I'm going to use. It also has an accelerometer, ambient temperature. There's also a radio module here from Sigfox. This radio module is actually what enabled the device to be able to send the data using Sigfox protocol over Sigfox network. So normally when you send this data on the backend, like I told you, sometimes it's encrypted and also encoded. And data is normally on base 16 in hexadecimal. It basically means that when you receive the data, you know that the first 3 bytes, for example, is latitude, the next 3 bytes is longitude, then the byte is light. So format, you normally get it from the manufacturer. For example, this one I got from WearFab, the manufacturer of this WearFab device. And I've also added another function in my code, which I'm going to show you, that actually takes the data and is able to get the latitude and longitude and light values. So this is also a more simplified one compared to the other one. So this is another device actually. It's an ESP, is a WearFab device, but running on a on ESP32. The other one was running on STM. And this one is also able to collect data from the environment, send it through the Sigfox cloud, and then I'll show you how to connect this Sigfox cloud with Google Cloud Platform. And through Cloud Functions, we push the data all the way to BigQuery. But with this one, you can also take it to different sides. You can take the data to data store, or have data store send data back to the device, because you may not just want the device to send data in one direction to cloud. You may want to have a bidirectional communication where the device sends the data all the way to the cloud, and also from the cloud you can also send data back to the device. Most of the time, the device sends telemetry data, sends the data from its surrounding to the cloud, and the data that you send back to the device is the metadata. It's the instructions that that changes the frequency of transmission on the device. For example, if the device was sending data 1 hour or after 15 minutes, you can decide to change the frequency of transmission of this data to once a day. So the way you can do it is through something called a data store, where you're able to put your hexadecimal data there, or hexadecimal payload, which eventually can go back to the device. So I think let's go to live demo before I talk about it. So like I said, this is the device we're using. This device and the WebFab device, they come in different variants. Some of them are running on STM32, basically ARM processors. Others are also running on ESP32. And this IT device, or IT dev kit, has sensors and also has activity on it. It has a radio module. You can see that at the very top, you have some antenna sending the message to the cloud. So let me go to Sigfox Cloud. Let me know, Tabby, if I'm able to. You can see the changes on the cloud. If you're able to see my cloud platform.
Yeah.
Can you see my screen for Google Cloud?
Yeah.
And if you can see it, you can see that the streaming here on or this is the invocations cloud function, and you can see data is loading on this graph. The last got here, the data point I got here was at 3, 4, and you can see that there are a bunch of data coming in. I turned on the device at around 11:30 a.m. today, and you can see the data is streaming here even right now, and it's active. So let me show you the Sigfox back. But before that, let me just show you the trigger. So these cloud functions normally have a trigger. Type of triggers. You can have triggers on Firebase, or triggers on HTTP, or triggers on cloud storage. But this basically create the REST API that triggers this URL and send a JSON. So just see here, it's the one actually I've taken, and it's the one that Sigfox over to GCP. You can see that this is the exact URL I'm using here, the one for lab, StudyJam lab. And when I get the data, or rather when the device, the dev kit sends the data, then it does a post request on this endpoint for the cloud function, and then send this data to it. So every single time the device sends the data, then it will do a post request on this endpoint and forward that data to my cloud function. And you can also see that data streaming here. This is the payload, which is in hexadecimal format. You can see, for example, this is first 3 bytes, which represent latitude. Then you have the next 3 ones, longitude, according to the data format I was showing you initially. And actually, that's a new data point which has arrived. What I want to show you in this backend is that normally we have companies represented as a group. So this device are put on a group, and then you may have family that behave in a similar way. You may have family of devices that behave in a similar way. So you may decide to put them on one device type. so that you're able to manage where they are. So if you have devices from company X that behave in a similar way, and by behaving in a similar way, I mean they send this almost similar type. So you can have it that way, so that when you want to change the frequency of transmission of data, or you want to change something on the device, you can always change it. Or you want to change the subscription on the device, then you have the devices. And these devices have a unique ID. For example, this one has this unique ID. And you can see that the data is streaming live. So function, I'm loading some data. Some data is streaming. I've talked to you about the trigger. Let me now go to the source code. So I want to run my VS Code. Let me just use this one here. So what I'm having is just a cloud function that receives the data from Sigfox. Then at this point, you can see that I grab that data. Then once I have it, I'm able to define project ID and BigQuery, because I've already created BigQuery. I've created my project. I've created the BigQuery, and I also have tables also in BigQuery. So I have the project ID and the table ID, which I define here. And then when I receive this, another file, which I'm going to show you, which is basically decoding this message, or rather decoding the hexadecimal message from Sigfox according to this manufacturer's instruction. So let me get back. So I require that module, then I decode it, and after decoding the message, then I'm basically pushing it to BigQuery. So that's my package. Just have this BigQuery thing, and my payload parser. You can see that I'm able to get the latitude from the device, longitude, temperature, and humidity. And that's what I'm sending to. That's what I'm sending to BigQuery. Or this is what I'm returning to my cloud function, so that my cloud function can store it in BigQuery. So I get the data using my cloud function. I call this module to decode that data. Once I decoded it, I should be able to have the latitude, the longitude, the temperature, the humidity, and then this is the data now push to BigQuery. Yeah, so that's my cloud function. Then this morning before when I read this query, having 70 entries. Probably I could run it again and see how many entries I'm having at the moment. So you should see this 70 changing once I run it, so that you can see that indeed the true in BigQuery. Is it the first 70 I'm out? Oh yeah, this is the first 70. Okay. If I move, I should should probably go to 100 records and see. Let me run it again. Alternatively, I could go to logins to view logs and see my logs. So I just want to run the logs so that we are able to see that the data is being decoded and is being stored. So there's this log. Okay. So for example, here you can see at the start, when I get the message, I also when the function starts to run, first of all, I get the format, like this one, for example, this payload. And once I have it, then I run that parser, the parser that I showed you, so that the parser can decode this message and tell me. Then the next part here, you can see that I have the decoded message. You can see that I have latitude, longitude, and temperature, and then humidity. One BigQuery. Yeah. Right. So let me go back to my deck. So that's the demo. And we've sent data to BigQuery, which you can run the query and see the data. And another good thing is that once you have the data in BigQuery, you can be able to even deploy your Jupyter notebook on the data and have some ML on it, be able to get the outliers on this data, remove the outliers on the data, remove the missing points, prepare the data nicely, and build some AI models on this data so that you, apart from just offering an IoT solution, you are offering an AIoT solution, AI and IoT. And you can also decide to take this data to studio where you're able to visualize the data and be able to have graphs from it. In fact, they make it so easy for you in where you just go to export data and then you can explore the data in Data Studio. You just need to specify the x-axis and the y-axis, then you'll be able to have the data visualized. All right. Let me go back here. Yeah, so that's you've seen the transmission of data from device all the way to Sigfox backend and all the way to Google Cloud and BigQuery via Cloud Functions. Where Cloud Functions is basically listening to these messages and helping in grabbing the data, processing the data, and also storing the data in BigQuery. But then again, also like I told you, you can set up another hexadecimal payload on Cloud Firestore so that rather than having one directional communication, you're also able to have bidirectional communication from device to cloud and also from cloud to device. And in Kenya, people are able to build different solutions using the network and different cloud platforms, and a bunch of use cases are coming up. New business models coming up. We have people who are doing asset tracking, and I'm going to talk more about it. Other people are doing asset monitoring, like gas and fridges. We also have a bunch of guys doing water metering. And do some smart irrigation in it, or monitor the quality of air in a place, or even try to see if you're able to detect smoke in an area. And let me jump to transport and logistics. And the integration is pretty simple, where you may want to know where your truck is and where your cargo is, and you want to know the conditions of the truck and the cargo. How are people handling your cargo? How are they moving it? So you can have a accelerometer on it. You can have something that gives you latitude and longitude, GPS module on it, and then always be able to know where your device is, or rather where your cargo is and how they're being handled. Also want to know the temperature of their goods, because apparently there's a particular temperature that will tell you that the food is okay or not okay, and also a particular temperature that should tell you when that should maintain one quality across all the products. For example, the guys who are having drinks, if someone in Nairobi has a fridge at a particular temperature, and another person in another part of the town or in another town is having a fridge with different temperature, with drinks in a fridge with different temperatures, these two people will have different quality of drinks they're having. And collecting that temperature is very important for them, because when they're able to collect temperature from all the fridges, they're able to ensure that the temperature is similar, and that way every single person is going to have one quality in the drinks that they're drinking, and that way you're able to maintain your clients and not give them the drinks you're having. I told you that the network is across the country. The device I've shown you that we've tested, it's actually sending latitude and longitude. And it means that you can also have a tracker that you can put on a truck, or people, let's say some people are going to climb a mountain and you want to know where they are when they're climbing the mountain or when they're hiking, or you want to track a cargo from one location to another. This is actually an actual map I've taken from my screen. That's showing how someone moved from town A, or rather from Bungoma, all the way to Nairobi, with this device sending data to cloud and to a Google map like this one. There are also people who are in a warehouse and they want to be able to track pallets from one location to another. You can have smart devices that are attached on pallets, that are attached on forklifts and on trucks, so that you are able to have a visibility of where cargo is. of where your pallets are, and you're able to know where they are and be business. And as you can see from the left, you have the device or a tracker or an IoT device on a pallet sending location data, and as the raw metadata that's going through the network to cloud, which you can take to Google Cloud and then visualize it on a map. This is another map with another device sending data, location data, going to western part of Kenya, places like Rongo. And I took this screenshot some few weeks ago. This is another way to visualize the data. And ideally, you should be able to, you can be able to create a complete new type of solution with having these devices send small amount of data or send location data in different tracks. You've also have people track cargo from Mombasa to Kampala. Some people are putting these trackers. This is an example of the tracker. For example, some global clients are putting these trackers on trucks so that they're able to locate where the trackers are. They're able to know which trailers are being used, which ones are idle, and ideally just to have a visibility of where these trucks are. And also, if there's an anomaly, then the device should be able to send data back to you or an alert back to you so that you're able to monitor the devices, you're able to set up maintenance dates and control it. And this device comes in different shapes and sizes. So as you have seen, it looks like IoT is a very big ecosystem. It's a wide ecosystem where you're having people building devices and you're having people providing network and also cloud. Sometimes it's very hard for someone to be able to be good in building the devices, designing the circuits, designing the schematics, and doing the impedance matching on the device and ensuring that the device works well, designing the enclosure, and then you set up a network of your own, and then also work on cloud or on platform on your side. So I think different people can focus on different areas and then integrate the solutions together. Partnership to have someone build for your device, or you can buy a device from a manufacturer somewhere, and then have someone provide for you a network. And then once you have the device and data to the network, then you can configure it to Google Cloud platform or to any platform you want to send the data to. Just about having different use cases. This is a global use of the network, sending data to a remote cloud somewhere. But these guys are able to track different parts of their Airbus, so that they're able to know where these parts are from the warehouse and when they're traveling and when they get to another warehouse. If they're able to have a visibility of where these different parts are, then that way they're able to have efficiency in how they're running the things, and they're also able to avoid delay on the process when you're connecting these devices. Yes, so they come in different sizes. Probably could just jump to another use case. Then also you have people who are trying to monitor fridges. I told you that different drinks sometimes have different qualities. You may want to maintain your fridge at a particular temperature and know how many times people are opening the door and closing the door. You can have a smart device that tells you when a door is opened and also tell you the temperature and humidity in these fridges so that you're able to maintain quality of your drinks. Another main use case in the country is smart water metering. What you see here is a smart water meter in Kajiado, Kenya, that is sending data through Sigfox network and taking it to Google Cloud to BigQuery, and so you're also able to visualize it in Data Studio. So so some people also don't want to. Some people also don't want to replace that is existing, and they may opt to get a device like this one that is basically taking pulses from an old meter, like this one, for example. So this old meter, you don't have to replace this old infrastructure. You just get something called a retrofit or a device on top of an existing water meter, and this retrofit is able to read pulses read pulses from this water meter and be able to know if there's alarms or if there's leak, and also give you consumption data. This device, for example, you can see that it lasts long in the field for 16 years. You put it here, you don't worry about it for the next 16 years. This other one also, you attach it here, you don't worry about it for 5 years. And these devices are not attached to electricity. They just have AA batteries inside them, AA batteries, and they can last long with them for 5 years. So it basically means that this type of network and this type of solutions, they are basically meant for things to communicate. It's not like you're tweaking an existing network. Like right now we have 2G, which is meant for people to be able to communicate with each other. 3G, 4G, and 5G is coming. So you don't necessarily have to tweak a network that was meant for people to communicate, but you can have a complete, they're calling low power wide area network that enables these IoT devices to send small amount of data and last long in the field. This is some live data from it. This is another device that's reading data from the tank. It's a very interesting use case because you can create a virtual grid of tanks with this one. You can have a bunch of customers having different tanks in their houses, and also providers. So some people have more water than they can use in their houses. Some people have less water than they can use in their houses. And that way, you can be able to have smart devices on top of these tanks. And these smart devices can read the level of water in those tanks and send for you the data on one platform so that you can know that each of tanks, this is the amount of water that I'm having. And the guys who have more water can add water to your grid, and the guys who have less water can buy water from your grid. Something like an Uber of water, and be able to enable people to easily sell water and also allow other people to easily buy water. So these are the kind of new business models that you can create when you connect things to communicate with each other. These are like a live data from it. You can also connect LPG, bulk LPG gases, where you have a smart device like this one, read data from these gases, or rather from these bulk LPG tanks. They can read pulses from it, or rather they can get consumption data from it, or get the tank level data from these tanks, and then send it to the network, and you should be able to visualize it on Data Studio. And the data is passing via the Sigfox network to your cloud functions for processing, and to BigQuery for storage, and then to Data Studio for visualization. The same thing I'm talking about, which is here. You have a device on a meter, and also you have another device on a tank. This one can be reading for you the tank level, and this one can be reading for you the pulses, which you can convert to kgs and know the consumption of these gas meters. Then send it over the network all the way to a cloud, then visualize it on a platform. What I'm talking, this is an actual meter, an actual device installed on a gas station, where this meter, this IoT device is attached to this gas meter, and we have a filling meter. It's basically filling gas, I think, to another tank, and then you have another decanting meter on this other side. This IoT device is able to read consumption data, gas data from this gas meter. This is basically a gas meter, and this is a gas meter. So it's able to send for you two different type of data from it to a cloud platform. This also other devices installed, and this device send data through Sigfox, the same way I was showing you, and you can take it to BigQuery via cloud functions. Yeah. Do remote reading for LPG tanks, LPG cylinders, similar thing. And guys are using them in different ways. In mining industry, where you want to track different machine parts, or you want to track people as they move underground and know that they're safe where they are. Another use case is agriculture, where you can have a client who have a very big farm, and then realize that this client, where they are, it's an arid area, and probably they have to pump water from underground and take this water to a tank, or a reservoir. And this client may invest heavily on the generator and pump water to the reservoir and also pump water to the tank. But how will they know the amount of water to apply and when to apply this water? And the client also probably has fertilizers that they want to distribute on the farm. How will they know the right amount of fertilizer to distribute on the farm, and also when to distribute this fertilizer? So you can have smart IoT devices that give you visibility about your farm. These IoT devices, like this one, for example, on the right, you can have a rain gauge, you have a wind speed here, and then also you have relative humidity and temperature here. And these devices this device can get readings from these sensors and then send it to you to cloud wirelessly without you having to add any infrastructure here or having you connected to fiber or anything. This device can communicate wirelessly about the weather conditions in this area, can give you a precise weather condition of your farm. And that way, let's say they wanted to sprinkle water in a farm. If you know the speed of wind, you'll know when to sprinkle water in the farm, for example. You won't just sprinkle water when it's very windy because you will end up wasting water. And also, as you waste water, this water is probably mixed with fertilizers. Then you may end up not just wasting water alone, but also fertilizers. And the rainfall that you're getting here, which is precise to your location, should also tell you if there's enough rainfall in the area or if you need to water that farm. So also what you're seeing here is another type of sensor that actually goes to the ground up to 600 millimeters or 60 centimeters, and 10 centimeters up to 0. You have different sensors. You have a sensor from 0 to 10 centimeters, then from 10 centimeters to 20 centimeters. Temperature that can give you temperature data and also moisture data from a particular block in the farm. That way, you will be able to know the drainage in your farm. You'll be able to know the soil water consumption of a particular block in the farm, and you'll be able to actually know when to water this farm, and also know how much amount of water you need to water this farm, because you're having every single thing on a platform, on a dashboard, and you just have a notification that now I need to sprinkle the water, or get a notification that the pumps have started because there's less water in a particular block in the farm. And you can enable plants to grow and just water the farm at the right time, and reduce your cost and improve efficiency. Rather than having people go to the farm every single time, you can just have all these devices collecting for you the data so that you're able to visualize it and make informed decisions. This is another sensor, and this sensor is actually getting the different chemical level, and you're able to know how much you mix the chemical. You can in fact also compare it with another one, which also has almost similar type of sensors. They can tell you something called electrical conductivity or salinity or pH, and that way you'll be able to know if the chemical levels in the reservoir is different from the chemical levels in your farm. And when you're able to get this data, you can be able to send data to Data Studio, like what you're seeing on my screen right now. This is live data. Rather, this is a screenshot of live data from Data Studio. This data is passed through BigQuery, and there's a cloud function receiving the data, decoding that data, taking it to BigQuery, and finally to Data Studio. And in this place, you can see the visibility of your farm. You can see the weather station. There's no rainfall at this particular time. This is humidity. This is the wind speed. This is the temperature. I mean, you can have you know what's happening on your farm, and you can control how you're applying your fertilizers in your farm, and control how you're applying water in your farm, and also know when to add this water or apply this fertilizer. This is the live data from Data Studio, and it's giving you the different levels for example, you can see level 1, the temperature of it, level 2, the temperature, level 3, the temperature. Also, you have the one for humidity here. And you can see the patterns, how they're changing. And the chemicals, okay. So for a technical person, moisture data and temperature data may not look as very important, but this data is very, very important to agronomists and people who are in agriculture, because it enables them to make decisions that will be able to enable plants to grow very well and enable them to have improved yields in the farms. So it's very hard for you to do it with 4G network or 3G network because of the power consumption and how that's sending data, the coverage. But if you're using small IoT devices that just send small amount of data, then it should be very easy to use it that way. Yeah, and people are using it to do air quality monitoring. And another interesting use case is for Industry 4.0, where in an industry or a factory, you may want to know how your generators are behaving. Are they just about to break? How can I have a predictive analytics on my factory? Because at the end of it, there's a particular time when a generator will break down. This generator can break down. You can get a notification before the generator breaks down, or you can wait and just get yourself, or just realize that the generator is broken down. So probably it could be a good idea if you add, or certainly it's a good idea if you had a device like this one that can collect vibration data from a generator and then send it wirelessly to a platform where you're able to visualize the data, know when the data were logged or the vibrations were logged. And then you're able to do analytics on this data, and you're able to detect anomalies on the data, and you can be able to predict when the machines are going to break down, so that you are able to bring your maintenance engineers to maintain the generators, and enable yourself to have a constant flow. So this data, when you get this data, is very interesting. Traditional methods to analyze the data. You can do a Fourier analysis of this data if you are so much into electrical engineering. Analyze the data, do summation of it, then make predictions with it. If you're also so much into deep learning, you can use deep learning techniques on this data and be able to detect anomalies, so that from your house or from wherever you are globally, you're able to have a visibility of all your generators, know which ones are working, know which ones are just about to break, and know the period when they're going to break. That way, you should be able to organize yourself so that you have you're able to have a constant flow or in production. Yeah. So they come in different sizes and shapes. You can connect people, water metering, they're being done globally. There are a bunch of manufacturers, but most of them are from outside the country. But I'm happy that right now we are also having people in the country who are also trying to build these devices. And I also want to encourage all of you to not just focus on building mobile applications, or building your applications for your mobile app, for your mobile phones, or for laptops, or for tablets. It yourself as a developer in just building apps for mobile phones or for tablets. You can also build for your watches and build apps for IoT. So your IoT journey awaits. Thank you so much for this session. Over to Tabi.
Awesome, Marvin, for enlightening us as IoT and everything concerning that. Like, yeah, that was really informative. There are a couple of questions from the audience. So how would you rate the adoption of IoTs in Kenya?
Yeah, so I partly got your question, but I heard about adoption of IoT in Kenya. Slow, because we didn't have a good infrastructure for IoT, because someone who was supposed to build and design his own hardware or design his own device, and then also build his own network infrastructure, and then go ahead and build his own platform. But this way it's not really scalable, and right now we have a network that is there across the country, like I showed you on my deck. And this network enables people to be able to get devices from somewhere. If you're a developer and you don't want to deal with hardware, just buy an existing device. You can buy a water meter, have this tracker send data through the, and once it has sent the data through the infrastructure, you can have this data to BigQuery or to Google Cloud, and even build your app that reads the data from the infrastructure. So right now, I believe we have the infrastructure that can enable different people in different verticals, the guys in hardware and also the guys in platform, to be able to utilize it and leverage on it to build solutions. And that means that right now people should not be tied to just building solutions or mobile applications or Angular applications just for finances. You can also build applications for IoT, for gas meters. You can build applications for tracking elephants, or application for telling you how much water you're consuming in your house. So right now I'm seeing the adoption speed increasing because we have the infrastructure and the ecosystem is becoming very vibrant. We're having more devices. For example, in Watermeter, you can see that we have a variety of players, from Elster to Itron to Campstram to Zena. It basically shows you that the ecosystem is mature and people are building more solutions. I hope I answered the question.
How effective are the use of IoTs in the remote or rural areas?
It's very effective, very effective. For example, let's say you have a very rural area, which is kind of hilly, and there's no good network 4G or 3G, or there's probably just edge in that area. Edge or GSM, it's probably just a network for people to use. And this area is very far away from electricity connection, but you have water meters in that area. So you can have smart water meters in those very remote areas, because the Sigfox network covers those areas. And your IoT devices, or rather your water meter, should be able to send the data to the network all the way to a cloud platform. And once it's in the cloud, you can decide to visualize it on Data Studio, or decide to build your own mobile application or web application, where the water authorities are able to easily monitor or know the consumption of water in these different areas. They're also able to know when there's a burst or when there's a leak in an area. So that way you realize that the IoT solution is not only going to affect the people in cities and towns, but also going to affect people in very remote areas, because these solutions can be implemented in those remote areas, so that someone doesn't have to. The people who are reading water meters in remote areas, sometimes you go to someone's house and there are dogs in that homestead. It's very hard for you to go and read water meters in those homesteads, or they're very far from each other, and you don't know if the water meters are active or not active. But if you have these smart water meters in those remote areas, which don't even have good connectivity for Internet of People, don't have 4G connectivity or 3G connectivity or 2G connectivity, these different dedicated network for IoT devices can send for you that data and allow authority.
Marvin, I think I lost you.
If it's between a challenge between the guys who are being charged, because sometimes they don't agree on the accuracy or on the values or on the readings from the water meter. But if the person who is being charged can know the amount of water they have used, and the person charging them also know the amount of water they used, then certainly they're going to agree on the amount of money they're being charged on. So IoT, the IoT solutions, is not only going to affect the people in cities and towns, but also going to affect people in very remote areas, because sometimes they don't agree on the values or on the readings from the water meter. But if the person who is being charged can know the amount of water they have used, and the person charging them also know the amount of water they used, then certainly they're going to agree on the amount of money they're being charged on. So IoT IT solutions are coming in different ways and affecting both guys in cities and towns and also people who are in remote areas.
So still on the adoption rates of IoT in Kenya. So what do you think are the impediments to IoT adoption in Kenya if the adoption rate is low? I mean,
No, the adoption is actually increasing. It's not slow. It's increasing.
okay.
In fact, I believe that in the next 2-3 years, all of us will be having smart water meters in their houses, the same way that all of us moved from Kabambe to smartphones. I mean, there's a change that's happening. There's a change that's happening in the background. People are increasingly having smart water meters in their houses, having smart electricity meters in their houses. They're having smart trackers in their warehouses. There's a growth. There's a growth for IoT devices. They're increasing, and actually, there's a point where one day IoT devices will be more than the devices that people are using. Will be more than the laptops, computers, and tablets. So that's increasing, and the reason why it's increasing is because of the big ecosystem. In terms of manufacturers, we have a variety of manufacturers who are building in different verticals. We also have a variety of cloud providers that are able to help you ingest the data in that cloud. It also help you process the data and even store it. In Kenya, I think right now probably the biggest challenge is that most of the hardware not built in the country. Most of the hardware coming from Europe and China, and some of them from South Africa. It basically means that if you want to, for example, have a smart water meter, you'll have to buy it from South Africa, or buy it from Europe. But to have local distributors. But the challenge is that they import it, and when they import it, you know, the added cost and everything. So I think now is the perfect time for our electricians and mechanical engineers to be more practical in their approach or rather in their career and be able to build more hardware. It's very hard to build a mobile phone, for example, but building an IoT device may probably not be as hard as building a mobile phone. So this is the time for our electrical engineers, and not just electrical engineers alone, but all the makers from different backgrounds to be able to build devices for asset tracking, devices for cold chain, devices for utilities, water metering, and also this is also a chance for our software engineers to be able to diversify the type of apps they're building, so that they're not just locked into building solutions for people or locked into building mobile applications for financiers use. They can also build solutions for water metering, solutions for gas metering, that when you're in your house, you don't just wake up one evening or morning, or you don't just realize at one time when you're cooking that you don't have enough to cook that meal. What if you're always able to know the amount of gas you're having, that I'm remaining this amount before I refill it? So the guys in software and also the guys in hardware engineering, or the makers and the coders, should diversify and become more practical and build the solutions.
Yeah, that is very interesting. So speaking of these IoT devices, how cheap are they, or are they expensive, or are they affordable?
Yeah, so the price of the devices in connectivity, both IoT device and also the IOP or Internet of People devices, their prices depends on different things. For example, your 4G phone and your 5G phone price may depend on something called a radio module. The radio module for 5G will be very complex, but it may be very complex. And if you're using different modulation techniques and different frequencies, then it could be more expensive compared to the 4G phone. So that's why, so that radio module will make the phone more expensive compared to 5G phone, more expensive compared to 4G phone. It may make 4G phone more expensive to 3G and to Kabambe 2G. So also, IoT devices have radio modules, and this radio module, like I told you, they have a different protocol and network architecture compared to the one that 4G has and 2G has. And having different network architecture and different radio module and different communication protocol enables you to have a different type of radio module that will have a different cost compared to the cost of IOP device, Internet of People devices, like Samsung phone, for example. So IoT devices with the technology they're using, they'll cost less compared to the people devices, or 4G devices, 3G devices, or the cellular devices. The cost for IoT devices range from 1,000 shillings. Some sort of cost 20,000 shillings, but trackers, like in asset tracking, they cost about 4,000 Kenya shillings.
Okay.
Laptop, I think, I don't know, 100,000 shillings or 50,000.
Okay. Well, on to the last question. So for those IoT devices connected in the farms, what power source do they use? Do they use solar or do they use battery?
Those devices relies
They,
completely on battery,
oh,
the ones on the farm, and they run on AA batteries, the AA batteries that you normally buy for 1.5 volts. They completely run on those batteries. And because of the protocol they're using and the connectivity technology they're using, 2 or 3 AA batteries on those devices, for example, the one for moisture sensor, can last very long. Can last as long as 5 years. The water meters I showed you, let me take you back to it. This water meter here. Let me show you the one. Is it? The water meter I showed you, it can last in the field for, this one here, it can last in the field for 16 years and just runs on AA, some small batteries on it, without you having to touch it or replace it. But every single day, it should be able to send you a reading that this is the consumption in your house or in your farm. And that's very good for IoT devices.
okay. Thank you so much, Marvin, for enlightening us on IoTs and IOPs. I'm sure some people didn't really know about IOPs. We just heard about IoT, and that's all. So yeah, thank you so much for taking us through that wonderful session and enlightening us, informing us on different things that we need to know. Yeah, all about connectivity. Yes, and thank you also to our audience for being an amazing audience since morning. Yeah, ever since we started the first session, and if you stayed with us till the last session, we are really, really honored and we're really glad. And we really wanted to say thank you for taking in your time, to spend the day with GDG Nairobi. And we hope that you really learned a lot, from the whole Cloud Next experience. And yeah, like we mentioned before, we have other events coming up. And yeah, be sure to follow our social media pages or check our emails, for more information on when the next event is really, going to happen. We have the Cloud Study Jam and, yeah, and other interesting event that will come along, and like we mentioned, this is the platform we are going to use until the pandemic is over. So while you stay at home, we hope, and I hope that you are keeping safe when you go out. Make sure you practice social distancing, you wear your mask where you need to have your mask on, wash your hands where necessary, because we really want to have you on board when we go back to having our physical events. Really can't wait to see you all looking healthy and interacting with everyone in the community. So yeah, just do your best to really take care of yourselves, for the goodness of the whole community. Thank you so much, guys, for tuning in. And yeah, if you want to subscribe to our channel, subscribe, to the GDG Nairobi channel. And yeah, if you need to recap or if you need to check, past events, just feel free to go over the content and learn. Yeah. So thank you so much. So a big thank you to the amazing team that really put this whole event together. There are guys who have been working on the background. You've not really seen them, but yeah, you'll get to meet them. Yeah, once we wrap up the whole series. Yeah, a big thank you to the entire GDG Nairobi team for putting this together for the sake of the community. Bye bye, everyone. See you next time.